Hello guys, Assalamu alaikum and good morning everybody. This I'm going to take this classes today about the Newtonian mechanics. Yeah. Hello guys. Are you recording me? Yeah. So try to join. I am just started my classes in sharp 11 a.m. in the morning. And I hope so everybody is fine due to the COVID-19 breakdowns and everybody is locked down at home. It's very sorry to say, and we can't conduct our schools at the moment, again college as well. So we hope so everybody would be fine, and we pray for everybody would be fine. Okay, so today I'm going to take classes about the Newtonian mechanics. So we do some common circuits about this in a banking angle, moment of inertia, and radius of a gyration. Okay, so in a banking angle, we see that what's the banking angle? Banking angle, if you see there is a turn in a hilly areas, we don't see in our country, maybe in Chile or China, because when the buses and trucks are taking turn, you see in a YouTube, there is the road is in the outer layer is a bit higher than the inner side because then to avoid the accidents. That's the angle they have made with the road, not a plain road or something like that. It's the angle to make this road in like a little bit angle with this in a horizontal positions. This is known as the banking angle. Okay, so see here you see in a picture where it says the banking angle. The road is something like that because here is a great depth in this in hilly areas. The car is coming like that. This is the road surface of the road, and car is coming like that, and taking when they are taking turns, the road is little bit curved in here. Okay, as well. So you see some of the races on there. You see in a car race there is the road is always in curved position. So the track is coming like that way. In this figure we see that. So we find out the what is the how can you identify the banking angle. So banking angle, we see that there is a car is coming in the curved road which is coming in this side. When anything is coming in a circular positions of a curved road is taking turn, there is a centripetal force is acting in the middle. Okay, which force? Centripetal force is acting in the middle. So we see that the centripetal force here is acting towards the center. Okay, the road is curved in here. Those side, when this car is taking the curved positions, there is a resultant force is separated by two sides. Suppose in normal positions, the resultant forces are cos theta, and opposite definitely are sin theta. Though r sin theta is working as a centripetal force, something which is in the middle. So r sin theta, we can write it down. Centripetal force from the formula we know the mv square by r. F equal to mv square by r, centripetal force formula. Okay, and r cos theta equal to this cos theta is directly related to his weight. W equal to we know is mg. So r cos theta equal to mg. So we divide the equation 1, equation 2. So if we divide it, we get it is in a tan theta 1 divided by 2. Tan theta, so mv square by r divided by 1 by mg. So we get it b square by mm is stopped rg. Okay, tan theta equal to v square by rg. So theta equal to tan inverse v square by rg. If a car moves comes in the definite velocity and this radius of this track is r, then we can find out the banking angle theta equal to tan theta inverse v square by rg. Okay, got it, guys? Clear? And another way we can find out this our banking angle. If there is a given the road surface is the road where it is coming in, a width of the road is given is x. I think it's like that. whatever the rho x and height is h, and there is a theta angle. So we can find simply by a sine theta formula. So sine theta equal to x by h. So h equal to x sine theta. Is clear? Yeah. Easy. Yeah. So we are going to do one of the CQ which is related to the banking angle. Okay. So we keep this one away. Bring it. That's one. Let's try to practice at home and different types of maths which is commonly related what I give my past lecture. So it is very easier for you to understand that. Okay. So there is a banking related CQ. A train moves with a velocity of 60 km per hour, and while it takes turn for a rail tracks and which radius is 328 meter, it falls on an accident. Okay, when the train comes in 60 km per hour, it falls on an accident when it's taking turn. The distance between two sleepers, the sleepers of two train sleepers, is 1 meter. Definitely broad gauge. An outer sleeper is 7 centimeter. Outer sleeper is 7 centimeters higher than the inner one. Okay, the banking. The outer one is 7 centimeter higher than the inner one. So what they say? What is the banking angle? And number D, what is the reasons for accident? So reason for accident, we can find it later. First we find out what is the banking angle. Okay, very simple. Because then when what is given, they see that the distance between two sleepers is 1 meter. So number C, 1 meter distance is given, and height is 7 centimeter. Height 7 centimeter, take it to meter, 0.07 meter. Okay, clear? Height 7 centimeter. We can make it 0.07 meter. So we can use this in a angle formula of the sine theta. So sine theta equal to opposite by sine theta is in a opposite by is in a hypotenuse. So h by d, there we write it down. So what it will get, theta equal to sine inverse 0.07 divided by 1. So it is likely to come 40 degree, theta equal to. That's the banking angle we have found. Guys, you will find it? Yeah, nodding. I'm fine, thank you. How are you? Guys, do you find it clear? Yeah? Aisa Sumaya watching where you are sleeping all time? No? You need to become to our classes because due to the epidemic, and you always check our classes online, because Army sir keep this time to every teachers to watching all the classes, and there is a time period is coming in every previous day which teacher is giving lecture in which section. So you need to be focused on this website, especially class 11 and 12. It is separated in our scholars website. Yeah, and then you can give answer, give so which classes is going on and what time. Please guys, try to attend all the classes of different teachers. They are doing very good jobs. Okay, because it's too difficult to give this in a lecture and all the time, because we don't have such a facilities at the moment. Number D, what is the reason for accident? Okay, we need to be find out reason for accident. So he is coming in the train 60 km per hour. If it is coming in 60 km per hour, it might be an accident. But we need to be check that what is the exactly 4 degree angle and what it would be its original velocity. Okay, so we need to be do number D, tan theta. We know that. So radius of a rail tracks, because you see the large rail tracks, it is they are taking turn, so its radius is provided r equal to 328 meter, and its velocity is given is 60 km per hour. Not necessary you make it meter per second. But if anything comes in meter per second, we make it kilometer per hour, then we see that is 60. So tan theta, we know that from the previous formula. Yeah, do you see that? Tan theta equal to v square by rg. Okay, we use this one. Then theta equal to, we write it down because it's the velocity v, we write it the v prime square by rg. Okay, so v prime equal to root over rg tan theta. So it is, see that r is 328, g is 9.8, and tan theta is tan 4 degree. Okay, and it's coming in 14.99 maybe. Yeah, we see in the calculator. Calculator, root over 328 into 9.8 into tan 4 degree. So it's coming in 14.99 meter per second. So 14.99 meter per second, we make it kilometer per hour. By adding is very simple. 14.99 into 3600, because the times comes up and 1000 is going down, that is kilometer per hour. It's coming in 53.96 kilometer per hour. Guys, do you see that? Yeah, it's lovely to watching. Yeah, there is comes in 53.96 kilometer per hour. If it is in a 4 degree banking angle, this train need to move in 53.96 kilometer per hour. But we see that it goes in 60 kilometer per hour, so the accidents happen in that time. Okay, clear everybody? You need to be write the decisions, because for decisions you know the Rubik's. The decisions is takes one number for this in a part D. So we need to be write down, though the train is moves in 60 km per hour, but the original it will be moving in 53.96 km per hour. For exceeding that limit, or you subtract 60 minus 53.96, that is causes accident. Clear everybody? So now I need to be go through my radius of a gyration, and what is that? Radius of a gyrations and moment of inertia. So be careful. Okay, this one you need to be download and take it in again. It's very simple. Actually the mass is oriented, the banking related mass is very simple, very simple, but you need to find out which was they giving, what is the radius, that is the length of these two rail lines, and in a banking angle, and also what height they are. You need to be very careful. I think so you can do it very well. It's very simple. The problem is sometimes this comes in radius of a gyration. Okay, I go through this another one. Now go see that everybody guys. Yeah, this is the radius of a gyration and moment of inertia. Yes, do I go faster or linear? Is fine. Anybody can comment that sir is fine? Is it? Okay. Very few students is watching. I don't know. Where's the guys? Where are all the guys? No boys is watching at the moment. Boys are sleeping. Very lazy people. They're watching later maybe. Okay. Radius of a gyrations and moment of inertia. Moment of inertia. Okay. Moment of inertia means if an object is moves with an axis. Okay. That is in every point there is a mass. You know the object is made up of lots of atoms and molecules. Because in every of this in a point there is a masses, and everywhere there is a different distance from the object. Okay. we see, suppose one of this point there is a mass is m1, and another is m2, this m3. So every object has a different differences of their from the axis. This is an axis you can say about x y axis. Okay, so moment of inertia, which is we can say about all the masses is moving with this one. So a moment of inertia said that the product of their mass and their distance from their axis, the square distance of their axis, is known as moment of inertia when all masses. So I equal to m1 r1 square m2 r2 square plus dot 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 dot, dot mn rn square. Clear? That's clear. Yama Sharia Jubin. Sharia, you fine? Yeah. All this Bandar Gula Gumai. Eh? Yeah, you friends is here. They are sleeping. Watching it later. Okay. Moment of inertia. Then we can write summation is summation of m I ri square. We can write it down because lots of there is even I don't know millions there's a particles as individual masses, and they are rotating. There's different radiuses from these sides. This is known as moment of inertia. Okay, clear? Radius of gyrations. In some books you have found that radius of gyrations definitions is very complex, but if you see that a very simple something, there is a radius of a gyration. When we are going to talk about there is an object, there is a center of mass in here. Okay, in an object is moving and there is a center of mass is in here. Okay, because all this mass is concentrated in a center, that is known as center of mass. The center of mass, and there is a distance from the axis is the xy axis, and distance from the center of mass is r. We can say about center of mass is capital R, we can say, but in this cases we say is different. But why is different? We talk about the center of mass. All the center of mass is rotating. All the center of mass is rotating in an axis is equal to rotating all the individual masses. Okay, the center of mass is rotating, that is equal to all the individual masses rotating. So from the center of mass to the axis is known as radius of a gyration. Is the radius we can express is k. So the relation between inertia and radius of a gyration is I equal to m k square. So k equal to root over I by m. Okay, clear? Radius of a gyration. So very simple. The distance from the center of masses to the axis is known as radius of a gyration, because center of mass is rotating to the axis is equal to the every individual atoms or every individual masses of an element is rotating of this axis. Okay, well, we need to know the two more things from this a moment of inertia and radius of a gyration before we going to do our one of this another very good CQ. Yeah. So if there is if in an iron shaft, you say that, okay, if it is moving with the axis and the xy axis, if it's moving with the xy axis, then we gain. Thus, if we're moving in the middle point, this is the midpoint. So first condition, midpoint axis. So axis is in the midpoint, then what if it be moment of inertia I coming in, I equal to ml square by 12. Remember, girls and everybody, okay, you need to be memorized this one. Midpoint axis for moment of inertia comes in ml square by 12, and radius of a gyration coming in k equal to l by root 12. Okay, clear? Yeah, guys. Sadman, Assalamualaikum Ustad. Hey, I'm a bus driver. Assalamualaikum Ustad. So midpoint is Sarpan is very funny guy. I love you, Sandana. Okay, the midpoint axis is I equal to ml square equal to 12. So radius of a gyration k equal to, we know that L by root 2. So in another point, it is in number 2 is if there is a axis is at the end of the shaft. Okay, at the end of the shaft, axis is like that in here at the end of the shaft. Then it's at the end point. Okay, at the end point shafts. So I equal to, we can write it down 1/3 ml square and k equal to L by root 3. Guys, I write down in the two formulas for this moment of inertia and radius of a gyration, but there is a couple of things you need to be remember. There's some of the formulas is coming in like a cylindrical shape. So what is the moment of inertia and midpoint is written very clearly in every textbooks. And what is the moment of inertia in a circular point, it passes through the middle, or tangent like in a circle, what it would be, and radius of a gyration as well is everything. In these couple of, I think 5 maybe, you need to be memorized that, because in an exam it's a very common, it's coming in radius of a gyration and moment of inertia. Otherwise you get in a lot of MCQs is coming in like that. Okay, be careful when you are studying on this one. So is it clear for you? Now we go for an MCQ. Is it? Jubin is clear? Rabia Khan? Only watching? Okay. So we need to be go the CQ at the right moment. There is a very nice CQ. Okay. Guys, you need to be go through all the CQs, because this CQs is not available at anywhere. But you need to be do that what I am giving you lecture. You need to be copy that CQ as well. Later and after what you like. Okay. The length of the rod is given that, which is the 3 different axes. Okay, CD is the midpoint of the axis. It is in a midpoint. Okay, midpoint, and AB is this and only the very end point, and XY is between the CD and AB. Okay, so they said that Pn equal to N means the XY axis is in the middle. This is the iron shaft in PQ. Okay, so they said the Pn equal to N, that means XY is the middle, that means 1/3 of them. Okay, Pn equal to N. So we need to be first what they said that calculate the radius of a gyration of the XY axis. They said that radius of a gyration in XY axis. So we know that in a half of this, and we know the formula, half of them of the what would be happen radius of a gyration at the end of the point, what would be happening in the radius of a gyration, but we don't know what would be in a XY axis. So we need to be find out by this in a integration formula. It's a bit complicated. Okay, no worries about, because all you know that I done in the first year and second year, all you know this integration is very well. So number C, I'm going to start. Length of the bar is length of bar L equal to 8 meter. Okay, and mass of bar M equal to is given 2 kilos. Okay, okay, this length and mass is given. So mass per unit length equal to M by L. Okay, we need to be find out when anything is moving with a moment of inertia, we need to know that the mass per unit length. Okay, this is a very common or something. If you do the integrations in the whole, the integration is means that if you measure the one of the tiles, you can measure the whole tiles in a whole floor. Okay, this the integration is something like that. So when we are doing this type of math, when this they said about XY axis, okay, come to this point, it is the XY axis, and total length of it is L. If the total length they say that it is in a L, then is this one is L by 4, here to here, little distance, and here to here, thrice L by 4. Clear, guys? Yep. Daniel Potter is Ostit CQ. So mass per unit length is m by L, so L by 4 thrice L by 4. Okay, from this in to that in, because our limit is doing from L by 4 to thrice L by 4. Okay, because it's in an xy axis. So what we can write? Moment of inertia. And again, one thing that I said about, if he measure one of the tiles, then we can measure how many tiles is required in the whole floor. So integration is always works as little bit of the slices. So we think that this slices distance is thickness is dx, and from the inertia frame it is in a x-axis, x distance. Okay, clear? In always there is we need to be a slice of something, because you need to do this in integration. Integrations is measures there is a little bit of slices, then it measures the whole something and what is going to happen. Then we write it down, moment of inertia I equal to minus L by 4 thrice L by 4. Why I take it the minus L by 4 in here? Because it is in a minus L by 4 inside this inside. If you hold it like that, suppose I have a scale in here. Yes, a little bit. You see the scale? If I hold it from here, okay, and it will be rotated like that, then the limit is taking the minus sign from here, because I excluded these things and included here to here. Okay, so excluded this one is the negative sign, because it's from the rotation axis it will be opposite direction, so it is said the minus sign in here for opposite. Okay, clear about? So minus L by 4 is comes for the opposite directions from this moment of inertia, axis point. So 3 by 4 m by L s square dx. Clear? Okay. So m by L, we're taking the m by L out because it's not in this limit functions, m by L. And if we do this in integration of s square, we know that it's cubed by 3. Everybody knows that. Integration of x to the power n, x to the power n plus 1 divided by n plus 1. So it is s cubed by 3 minus L by 4 to thrice L by 4. Okay. So m by L, I take the 3's out from here because no need, the 3 is a constant inside, and is thrice L by 4 whole cube. We will be able to put the values of x in a limit function, so minus L by 4 whole cube. Clear about? Yeah. Okay. I take these papers out because then I need to be writing in other papers. Clear? Okay. Just take a couple of minutes. There's a lot of books in my table, not putting anything arranged perfectly. So what we have find it out, I equal to what I write it down, m by thrice L is the cube function is coming in 27 L cube divided by 64. I here is minus thrice L cube and L cube by 64. So what is coming in? M by thrice L into 28. There's the L cube in the, sorry, yeah, there is a minus means here is a plus in here, because you know that in there's a 3 times L cube means minus sign is coming in, and minus is plus. Okay, I'm doing a little bit wrong, so I write it down. There's a L cube by 4, so it is 28 L cube divided by 64. Okay, the 4 7 28, 4 16 64. So it is coming in I equal to 7m. L square and q is in 1, m is dropped, so L square. This is in 48. Understand, guys? It's clear. Sumaya is not, you don't finish in writing. Oh, I'm sorry, Sumaya. Which where you are writing in? Yeah. Someone is going to washroom. Sumaya, do you see that? Is it? Okay. This is coming in. Yeah, that's very good. Thank you, Sumaya. This is kind of I equal to 7m L square divided by 48. So the radius of a gyration R equal to, see, number C is quite long. Sorry, radius of gyration. Radius of a gyration. We know that K equal to root over I by M. So it's in root over, value of I is 7m L square divided by 48 into 1 by M. Mm is drops and root over 7 by 48. L square means 8 square because the length is given 8 meter. So it's coming in how much? Root over 7 divided by 48. 7 divided by 48 into 8 square. So it's 3.06 meter. This comes in 3.06 meter. That's the radius of a gyration coming. This is the finish number 3, C number CQ. Guys, do you clear about that? Okay. Everybody copy that? Jubin, you want the math of pulley? Yeah, I will show you. Sorry for disturbance. Yeah. So it's coming like that. Is in a radius of a gyration. This K is coming in. That's one. Okay. So number D. What's the question number D is said in here? D. You see that number D. D said that in which axis does it easier to rotate? In which axis does it easier to rotate? So we need to be comparing each. We find out the radius of a gyration in each axis. Then if we find this radius of a gyration is less, that would be very easier to rotate. So we need to be find out in every axis. Okay. Do you see that? Do you copy this one? Okay. So we need to be go through this one in front on the top of this. So we see that which axis is easier to rotate. Number D. So moment of inertia is said that is in an AB axis. The moment of inertia in AB axis. Yes, so you clear about? Okay. Moment of inertia in AB axis, that we know that moment of inertia, what is in our formula, you see, check that 1/3 ml square. Okay, girls, it will be written in the moment of inertia from the one end when I talked about earlier about that. So 1/3 ml square. So which is coming in 1/3 m means 2 kilos, L is 80 square, It's coming in 42.67 kg meter square. Okay, so moment of inertia now in xy axis. You see that perfectly? Yeah. Moment of inertia in xy axis. So what we'll see that xy. So what we have found that Ixy is 7 ml square, because in from the C we find out divided by 48. Okay, from the C we have found that moment of inertia 7 ml square. So 7 m equal to 2, L means 80 square, divided by 48. In calculator, we can do it very quickly. 7 into 2 into 80 square divided by 48. This comes in 13.67. Guys, I found when I checking your copies in the different examinations, and you are forget to write in every times the unit. So be careful about to write the unit. Okay. Otherwise, then I'll drop down every 1 marks for this in a unit. Unit is very crucial. And when you go for the board examination, if your number is increases, they will look up for a unit and cut down your number. Now the moment of inertia in CD, because CD in the middle point. Okay. Moment of inertia in CD axis. So it's the middle point. What would be the moment of inertia formula? ICD equal to, do you see that perfectly? Yeah. 1 by 12 ml square. So 1 by 12 m means 2 and L square is 80 square, which is coming in 10.67 kg meter square. Okay, this is what we have see in here. The moment of inertia is AB, from AB axis is very higher, from XY is middle, and from CD axis is very less. So ICD is very less than IXY is than IAB. So it is easier to, what I said that, and which axis the moment of inertia is less. So it is very easier to rotate. If you hold something and any shaft of a scale, if you hold in the middle, that is very easier for you to rotate, because you get in a less force to rotate it. So it is easier from easier to rotate in CD axis. That's it. Yes, do you find it? Very easy, busy math. Where is the other girls? Only 3 people are watching. Other guys is sleeping. Okay, they see that it's very easy. You need to be copy that one, and when it comes in anything, any problem is related to the banking, moment of inertia, or in elastic collisions, in Newtonian mechanics, this type of math is always coming in. Okay, so Newtonian mechanics, you need to be read this one is perfectly, and try to practice more and more of the different either you use the guidebooks or books whatever you're using. And also guys, be careful, start it MCQ many more times. Okay, MCQ is I know that there is a great disaster is coming in, so MCQ you need to be read more and more, and give this practice. There is some practice cases in somewhere else. You can give the practice questions and you keep the answers. It's very much helpful for that. Okay, so that's this all. This is the Newtonian mechanics. If I come in a live in another time, so you need to be writing down mentions which classes is very much important for you, either magnet or light or any of the classes which is a very tough sites, then I will do some important CQ from their sides for reviewing something. Okay, that's all right. Thank you very much. Thanks everybody. Take care. Stay at home. Don't go outside using masks. Keep a safe distance. Thanks very much.